So we're about three, bless you, we're about 3 PowerPoint pages away from finishing Chapter 4. So you're going to want to do the Chapter 4 quiz, exam, whatever they call it in MindTap. After, make sure you've done all of them, because that's about the best prep for the quiz, excuse me, for the midterm. You know, questions are drawn directly from that. So if you're acing that, then you know you already have a good leg up on the exam. We'll go over the exam before the end of class. Why is PowerPoint frozen? Why is everything I'm trying to get done frozen? Yes, sir. Yeah. Yes, ma'am.
And then you said we don't have class Wednesday, right?
That's correct. No class Wednesday, no class Thursday for those of y'all who have Thursday classes. All right. PowerPoint, I want you to go away. Finally. Okay, good deal. Once more with feeling. So if I do this, well, this is just the comments. So reminder, exam on July 8th for chapters 1 through 4. Best prep is to do the MindTap tests. Okay, so if you have this, x is equal to 3, y is equal to 7. And then if you have this, let me make this a comment. I just want somebody to tell me what it's going to print. Is it going to print A, or is it going to print B? Pretend the syntax is correct. Okay, so if x is 3, y is 7, and then our test expression is this, I'm going to put parentheses around it even though that's not necessary in this language, just hammer it in. Does this evaluate to true or false? So we got to break it down into pieces. Does and mean either side or both sides?
Both.
Both, yep. So here we go. They both have to be true. Is x equal to 3?
Yes.
Yes, it is. Is y less than x?
No.
Nope. So it's definitely not going to print A. It's going to print B. So if we have this, is it going to print C or D? Or, well, since and meant both, or means one side or the other. Or both, so much the better. So is it true that x is not equal to 4?
Yes.
Yeah, it's true that x is not equal to 4. So we've already got one side that's true. So it doesn't even bother to skip the other side. I mean, it doesn't even bother to calculate the other side. But if it did, is y greater than 3?
Yep.
Yeah, so either one would be enough to get it to print C. But let's make a comment here that since I can't type today, since x really is not equal to 4, the program skips evaluating the, slow down, evaluating the second part, the y is greater than 3, for efficiency's sake. This is called logic shortcutting. So when you're using or, put the expression least likely to be true first. Because if this is false, nope, that's false. Most likely to be true. I was thinking and for a moment. Because if this is true, it can skip this. That takes a little bit more time. If it gets to skip it, great. So you want it to skip the most often. So if this is the one that happens the most often, it should be first. On the other hand, if this second test happens more often, is correct more often than the first one, then you'd put it first. Now, let's talk about and. When using and, you want to rule out as quickly as possible. So if this one happens least often, it should be first, like it is. So if x is almost never equal to 3, great, it's worded correctly. Because if this is false, it doesn't bother to check the second one. So it gets a speed performance. It gets a performance gain by being able to skip the second one, because it takes time for every little thing it has to do. So when using and, put the expression least likely to be true first. So if you have this, A equals 1, B equals 2, C equals 3, and then you have this expression. I'm not going to bother putting it in an if this time, so we're just going to say whether it's true or false. Well, I am going to put it in an if just because that looks good, right? Which has higher precedence? Ands or ors? Which one do we do first? Just like multiplication happens before addition. And happens first, so we got to check this one out first. We skip this check for now, and when I say we, the computer does. And so B is less than A, is that true? Is 2 less than 1? Nope, that's not true. And so since both sides of an and have to be true, that expression fails. But that's okay, because this one might be true. Is that one true? Yep, so that one actually is true. Even though part of this one failed, then that is true. So the way this gets evaluated is as though there were parentheses around the and part. Like that. All I did is copy and paste it and put that. Now, it looks like even if we had tried to do it wrong, if we had tried to solve it with or first, then it still would have come out to true. But as long as you get the idea. Oh, and in this language, true is capitalized T. I should have been putting that everywhere. So some languages have something called a case switch command. Ours does not, but when you go on or when you see it in the book, you may see something like this. And so the way that looks is, what if you have something like this? Grade equals score divided by 10. So if their grade is 100, it results in being a 10. If the grade, or if the score, if the score is 100, it results in being a 10. If the score is between 90 and 99, or 99.99999, it results in being a 9. Score results in being a 9. Grade results in being a 9, right? So we know what floor division is. It divides it and then it rounds down. So we're just getting their score to like an even round number so that we can check 10 versus 9 versus 8 versus 7 to calculate an A, B, C, D, or F. So if the score is 80 is between 90 and 99, it results in a grade is a 9. Past that, you know, if it's between 80 and 89, 80 or 89 divided by 10, rounded down, is an 8, and so on. So the syntax for this in the languages that support it is switch based on grade, right? So remember, at this point, grade is a number between 0 and 10. And so then we do case 10 or case 9. If either one of those is true, we're going to print an A. And then we have to break out of the switch. Now if it's an 8, they made a B. So case 8, we print that they made a B. And then we break out of the switch. If it's a 7, we print that it's a C, because they made a 70 to a 79. And we're going to pretend that they can't make it below a 70 and pass the course. We're a really mean class. And so if they get below a 70, we're going to print F. And that's the end of the switch. We could stick a break there. It's not absolutely necessary because it's the end of the switch. Now that's just for languages that support it, but a lot of languages do. So you can see that it replaces if, else, right? Otherwise you'd word this: if grade is equal to 10 or 9, print A. Else if grade is equal to 8, print B. Else if grade is equal to 7, print C. Else, do this stuff. So let's say that we tried to write that, since we don't have switch case in Python. So we're going to rewrite this using if statements. And we may as well really do it. Let's just arbitrarily pick a grade. Let's say that our grade is a 99. So, score equals 99. Grade equals score floor division / 10. Now grade is between 0 and 10, assuming 100 as the max score. Alrighty. Now there's actually going to be a logic bug in the way that we first do this. Intentionally, and then we'll fix it. So if the score equals 10 or score equals 9, colon, print A. If the score equals 8, colon, print parentheses, quote, B, end quote. And then I'm going to do the C and I'm going to do the F. If score equals 7, colon, print quote C, end quote. And then lastly, well, I guess we better do an else here. Else colon, to handle the default, print quote F, end quote, in parentheses. Does anybody see the logic error before running it? Just thinking it through, if the score is a 99, what is it going to print? Well, 99 floor division by 10 is what? 99 divided by 10 is 9.9. Rounded down is, come on guys, start spitting out answers to me.
80.
Well, 99 divided by 10 is 9.9, and then rounded down is 9. So we've got a 9 here. So this part's true, right? So it's going to print an A. But then, okay guys, this is actually not a logic error like I expected it would be. This part would be correct, because if score is equal to 9, then it's not going to print a B. If score is equal to 9, is it going to print a C?
No.
No, but it is going to print an F because of the L. I said elf. Guess I have Dungeons and Dragons on a brain or something, Lord of the Rings. So, according to this logic, if the score is a 99 or the score is 100 or any version of that, it's going to print both A and F, which is uncool. We have to fix that by changing these to else ifs, or as this language calls them, elif. Like that. The elif makes them mutually exclusive, so that one and only one of these choices is triggered. We don't want the option of multiple choices being triggered. If it's something supposed to be like this, right? You can only make one grade, right? You can either make an A or a B or a C or an F. You can't, make multiples of them. So we want to use elif. Mutually exclusive just means one and only one of all the list. In the example above, if we just used if, then if they made an A or a B, it would also say F, which is not what we want. Okay, I'm getting worried that nobody was giving me answers for floor division. What is for floor division 2?
2.
Yep. So what is 5 floor division 2?
2.
It's still 2, exactly. So what is 4 modulus 2? 2 went into 4 2 times with no remainder. It was an even number. So modulus gives us a 0 there. How about 5 modulus 2? What's its remainder when 2 goes into 5? 2 goes into 5 2 times with a remainder of... All right. Everybody agreeing with that? Seeing some nodding heads? Awesome. Okay. So that's just a reminder. Just a reminder. And this is going to give us a syntax error, that 0 and that 1, so I better put these inside of comments. Well, anyways, let's make sure we don't have any syntax errors at this point, because we're going to keep wanting to run this. I think this is lecture I. Yep. By the way, it's okay to put spaces in your file names for this language, but in a lot of them, it's not. And that's why I don't. Lecture I.py. Just like you can't put a space in a variable name, let's pretend that's true of this language. Unless you have been already, right? I don't care. If you've been putting your name on it or something, that's cool. Okay. It printed out F. Definitely not what I wanted it to do. Oh, I made another serious mistake here. Does anybody spot it? That was really dumb, and that was not intentional on my part. By the time we get down here, and you told me this, and I didn't get it. By the time we get to here, what is score equal to? Well, it started off 99. Is it ever changed?
Yeah, 10 or...
Well, score stays 99 because it never changes. So there's no way it could equal 10 or 9 or 8 or 7, and so it prints F. All of these variables should have been called grade. And I'm sorry about that. That was absolutely not intentional. So why don't you just copy the word grade and paste it over all of those word scores? Right? Just the fast way to select is to double click, and then you can right click and paste. Double click, right click, paste. Just do that for all of those score variables. My mistake. Now it should be printing an A. Let's keep testing, because you should test with more than one possible result. We should test all the pathways. I want it to say A, B, C, and F. I want to test it every way. So I'm going to try an 80, because that should print a B. Thankfully, it does. I'm going to try a 79.999, and that should wind up being a C. 79.99. You see what I'm doing? I'm just testing each one in turn. That is good testing. So 60 should be an F. Anything below, nope. Yeah, anything below a C is counted as an F here. So a 60 was an F, a 0 should be an F, and that's about enough testing. So when you're testing, you don't only want to test it once. What programmers do is they test it and they see that it works, and then they wave their hands in victory, and then they go on to the next thing. But you should also test to see if you can make it fail. Because if it can fail, if you can figure out a way to make it fail, some other person's going to be able to make it fail. You know, like if you're a game programmer and you upload your game to Steam and 10,000 people download it, you can be sure that somebody or a whole bunch of somebodies are going to be finding the flaws in your program. So say I had not done elifs. It could be that if I entered like a 60, it would have in fact printed out an F and only F, and I would have thought the program was working because I didn't test it with a, you know, with a 100 or a 90 or an 80 or a 70 grade. So you got to test it more than once if it's something like this. If it's a mathematical formula, try things like entering 0 to make sure that it doesn't crash, right? Because division by 0 can cause it to crash. We can prove that real fast. I'm just going to print parentheses 10 divided by 0 in parentheses, and we're going to get an error. Division by 0. So if it's a math formula, like we've done, I don't know, interest rates and stuff like that, try entering 0 to make sure that it doesn't crash. Now, at this point, I'm not going to make you go back and correct it. But if 0 did make it crash, you would add an if statement. Something like this. Let's print a message, print parentheses quote, enter X so we can calculate the inverse. I think that's what it's called when you flip the fraction. So the inverse is 1 over 1 is 1, but the inverse of 2 is 1 over 2, so it should print 0.5. And the inverse of 3 is 1 over 3, which is 0.333, and so on. But if they enter a 0, then it's going to crash at a certain point. So my next line is just an input statement, and then I'm going to convert it to a float. X equals input parentheses, whoops, like that. If you feel like doing the thing where you tell them where to type it, you can put something between the parentheses. And then X equals float, not flat, float parentheses X. And now let's calculate the inverse. Inverse equals 1 over X, print parentheses quote, the inverse of X is, end quote, comma, inverse, in parentheses. So I'm going to test it a couple times. I'm going to test it with positive numbers, negative numbers, and then 0. And only one of those is going to crash it.
Do you have to get rid of the print or the 10 divided by 0? Or
Yeah, you're right. That's going to crash it every time. So just delete that line or comment it out. Doesn't matter if you deleted it. This would crash. Divide by 0. All right. Yeah, enter X so we can calculate the inverse. All right, I'm going to try positive number. So 1 over 4 is 0.25. I'm going to run it again. The inverse of 0.25 is actually 4 because 1 divided by 0.25 is 4. So I'm going to try 0.25. And we got 4. It's looking good. I'm going to try a negative number. What's the inverse of negative 3? Negative 3 is negative 0. Okay, it's working so far so good. But if I enter 0, it's going to try to calculate 1 over 0, which is a crash. Boom. float division by 0. So what we're going to have to do to make sure that the user can't break our program, of course there's another way to break it that we don't know how to fix yet. The other way to break it is just to enter bad data, right? Enter X, and so I type in X, plausible, right? That's what the user thinks they might want to do, and it crashes because that's not a number. But we don't know how to fix that yet, so we're not going to fix that, but we certainly know how to fix entering a 0. We just use an if statement. So I need to make sure that X is not equal to 0 from here to here, because this is the line that causes it to crash. So those two statements need to be protected inside an if statement that rules out the possibility of X being a 0. So after that float X, I'm going to do this. If X not equals 0, colon, and then tab those guys over, the next two statements, the inverse and the print, and we're going to now print an error message. So else colon, tabbed, make sure the else is all the way back tabbed, right, against the margin. Else print cannot divide 1 by 0. Parentheses and parentheses. And then why not a little comment? Not necessary, but since we do it in the pseudocode, there we go. So back tab against the margin, # end if. That's going to rule out the error, because if they do type in a 0, this statement's no longer going to be true. If X is 0, then X not equal to 0 is false, so it won't calculate the inverse and print it out. Instead, it'll jump down to the else and print that. And it ruled it out. So to my recollection, we have only flowcharted single alternative ifs. I could be wrong about that, but I'm going to quickly draw a flowchart for this. And by the way, lots of good flowcharts coming in. A couple of them looked a little bit strange, like maybe you were following a flowchart syntax that you learned in an engineering course or something like that. It was completely beyond my capacity. It's not showing what the book shows. It's not showing what I did in class. So just go and look at the examples that we posted in the notes and then check the book about it. Because honestly, you were trying way too hard. Took a lot longer to draw than it should have. Okay, so I'm going to go to Lucidchart and I'm going to draw that flow chart. If you feel like doing it, that's cool. I don't like it saying something about a free trial if I share it, because that implies I'm going to have to start paying for it. They keep changing the way that you used to sign up for a student account, and when you did that, you linked it to the teacher, and the teacher could go in and grade all your flowcharts right then and there without you having to save them and submit them, which is kind of cool. Oh, look at this. Maybe it's because I didn't sign in with an educational account. Let me log out and try that. Maybe they make it automatic to where if it has .edu, you get an unlimited account. Whew. Alright. Sorry about that if you've been trying to use your own account or something else. You better sign on with EDU accounts, or eventually you may run out of documents. If it ever tells you you have too many documents, you might be able to just go in and delete your old ones, but you could also just log in with your EDU account. Okay, so every one of these has to begin with a start. Some folks forgot to add a stop at the end or something like that. I'm going to drag this over to give myself room for the else side. All right. Now I'm going to shorten my pseudocode so that I don't do a print and an input. I could do that, but it's not necessary. So I'm just going to do, since this is pseudocode, since it's a flowchart, it's okay just to do input X. And I can skip the print statement, and I can skip the float line. Because all three of those things are necessary to get input, numeric input in this language. But as far as pseudocode is concerned, we can just do input X. Why not save ourselves the time? On the other hand, some folks did all three of those things in the flowchart. Cool. I'm not going to count you off for, trying harder. All right, so we input X, and then we're going to have a set statement. Sets are not in tilted rectangles. They are math, so they're in a process block, a regular rectangle. So set inverse, maybe I better zoom in, equal 1 over X. However, I had an if statement first. So really, that should not be there. I better delete that line and move that guy over so to be after the if statement. If statements are diamonds, decisions. Oh, bless you. All right, so if X not equal 0, then draw our line over here. We set the inverse and then we print it out. And we know what a print statement goes in. Not to even ask the class, because y'all already know. Everybody got that right as far as I recall. So, output the inverse. And if you were feeling like putting print there, the word print rather than output, I wouldn't count you wrong. I might ding you half a point if you did that in a pseudocode, because we've been told to use the word output in the book, and so I'm going to kind of follow that. Alrighty, so if X is not equal to 0, that's the true branch. But here's the else branch. This is a dual alternative if, because it's got two sides. It's do something else do, or it's do something else do something otherwise. So in that case, it's just a print, because there's no calculation if it's in an error state. And you can take the time if you want to stretch that over to look like the other side. Whatever. I'm not grading on artistic ability because I'm not much of an artist myself. So output, you saw me start to type print. Output, quote, cannot divide by 0. Or I could put the exact message that was in my program. I'm kind of going backwards since, I wrote the Python first. And then they need to hook back up, because every if statement hooks back up in a circle. If you feel like putting end if inside the circle, great, I don't bother. It's implied. Both of them need to join up. And the program is actually done at that point. So I'm just going to draw an oval and get it to the stop. Okay, this is a pretty good flow chart. The book would draw it a little bit differently. They wouldn't even bother putting a circle there. They just have the two arrows meet and a line coming down from that. That's just kind of hard to draw. That's the only reason I put the circle there. You can get it to work, right? If you messed with it enough, you might be able to zoom in and get, that to go there and that to go there. And if you wanted to do it like that, like the book does it, you might even have to delete these arrowheads. I don't remember if the book shows those two arrowheads or not. Well, the circles are good enough. Okay. The other thing the book will do is they don't show the word if. I hate that, because then it's not immediately obvious as to whether it's an if or an else. Excuse me, an if or a while. The only way you can tell the difference between an if and a while, according to the book way, is if you have the line coming back up here. And sure, that's a good way of telling, but it's way easier to tell if the word while is right there, right? So I put the word while and if there. If you feel like skipping it because that's not how the book shows, that's cool. All right, so this is a dual alternative if. It matches the code that we entered and it shows error handling. It prevents them from typing in 0 and crashing our program. So that was the point of that flowchart. We may draw another flowchart or two, but this is enough for that. Okay. I don't hear fingers typing. Anybody need a second more to get a flowchart drawn because you want to draw the flowchart and finish it? I don't see anybody waving your hand, but some people are shy. Okay. So, when and or operators are combined in the same statement, you have to do the and first. So you would make sure that you've worded it exactly so what you want happens is actually what happens, right? Because if you wrote a mathematical expression and you put the multiplication, you know, in the wrong order so that it evaluated incorrectly, the computer would give you the wrong answers. That'd be uncool, so you have to make sure that your logic is good. And if you're ever in doubt, you can always just use parentheses to force the issue, to tell the computer, right? Because then if we did it that way, it wouldn't matter what way we did it, right? We could stick the or on this side and stick this one on this side, and it would work just as well. So that'd be fine. In this particular case, the parentheses are not necessary because it would have worked anyways. What do I mean by that? And is always evaluated first, so we didn't need the parentheses. But if it makes it easier for the human to read, there's never anything wrong with making it easier for the human to read. So you can use parentheses to correct the logic and to force the evaluations to happen in the order you desire. Like in this one. Let me stretch that down so it's not in the middle of our... Here we're making sure that they're not within a specific range, that we're outside of a range. We've already said that if you're talking about outside of a range, if you're doing a range check but determining if it's outside of it, you use an or. So we're making sure. Is your age less than 12, less than or equal to 12, or your age greater than or equal to 65, then the rating is equal to G? Or wait, and the rating is equal to G? Then do something, whatever special thing that is. So if they had left the parentheses off, it would not evaluate correctly. Because what it would do is it would do the and first, and so it would look at all this, do the and then it would or it with that, which is not what we want because we want this part to be executed first. So in this case, the parentheses were necessary, but you could have reworded it. Nope. I don't even think rewording it would work. Maybe it would have, but putting parentheses around it's the best solution. So mixing your and your ors make logic more complicated. You can avoid mixing and or statements by nesting your if statements. So for example, this code here, what we could do is when you have an and, that could be treated as a nested if. What do I mean by that? I'm just going to put this in comments, save ourselves a little bit of typing time. But if my line is this, if age is less than or equal to 12 and movie underscore rating is equal to R, we don't let them in without parental supervision, but we're not going to talk about that. So we could have worded it like this. If age is less than or equal to 12, and then if movie rating is equal to R, then print, sorry, can't watch, end quote, in parentheses. That's a nested if. This if is inside this if, which we could have worded in a single line. If age less than or equal to 12, and movie underscore rating is equal to quote R colon, then parentheses quote, sorry, can't watch. Logically, those two things do the exact same thing. And this kind of shows that if you put the least common one, the one that occurs least frequently first, it won't even bother to do this second check. It just kind of calls that out explicitly, whereas we just have to kind of know that if it's written like this. But behaviorally, functionally, those are exactly the same. So if you have something with a whole bunch of ands and ors, and it would make it easier to read if you nested it, then great. Let's go back and look at that one that they had about the age being between 12 and 65. If age less than 12 or age greater than 65 and the rating is equal to G, okay, so this is going to be the nested part. So we're going to word this part first, the OR statement. So if age less than or equal to 12 or age greater than or equal to 65, colon, and then if movie underscore rating equals G, quote G colon, then do something, whatever we're supposed to do. Print whatever. I don't know what we're supposed to do there. It didn't show us. So logically, that's the same as it was before, but it makes it easier to read. If you feel like writing it with the ands and the ors all in one line because that's the way your brain works and you think it's easy enough to read, go for it. If you think that it's looking a little bit scary, like it'd be hard for somebody else or maybe even you later when you came back to it, then you can use nested ifs to try to accomplish it. Okay, now I'm going to do something stupid though, so don't do this. Don't bother typing it in. There's no reason to try to simplify your OR logic. You can't simplify OR logic with nesting. If you wanted to simplify the OR logic, it could look like this. I mean, you can type it if you want to, but it's taken me a while to type it, so why would you want to? Okay. Alright, so you see what's going on? We have an if statement. We do some stuff. Elif, we have another statement, and we do some stuff. This functionally is the same as this was, but we had to copy and paste some code, and it had to be in there twice, right? That we had to do this check to see if it equaled G twice. So whereas AND can be done by nesting, ORs have to be done by elif if you're going to write it this way. I don't recommend doing it that way, but let's put that in as a comment. AND logic can be replaced by nested ifs. OR logic can be done as if elif, but this is not recommended and leads to longer duplicated code. Right. I don't want it to look like this if I can make it look like this. Now, if we didn't have an OR operator in this language, that'd be how we had to do it. But fortunately, every language ever invented pretty much has an OR in it because it's a very common thing you want to do. that's just about the last slide. Well, we got about 5 more. But yeah, mixing and ors makes the logic more complicated. If you want to, you can nest your if statements to replace the ands. This is just showing a flowchart of that, right? Is a rating equal to G? Yeah. Then is your age less than or equal to 12? No. Is your age greater than or equal to 65? No. Output discount applies. All right, so that, you know, here they did the thing with some elifs, right? This no is actually an elif or an else if. As far as I'm concerned, it made the code harder to read. I wouldn't bother breaking an or statement up like that. We have 2 duplicated output statements here, whereas if we just use an or inside the diamond, then we only would have needed, you know, a branch on each side, and this would have been simpler. So the case structure, just talked about that. This is a specialized thing. That's the switch case. If there are distinct possible values for a single variable, now I call them mutually exclusive, but distinct possible values, it can either be a 10 or a 9 or an 8 or a 7 or a 6 or a 5 or a 4 or a 3 or 2 or 1 or a 0, right? So we use the switch case in order to do that. Now, that's why we did that floor division bit, to make sure that it fit into those distinct cases. And then if each value requires a different subsequent action. So like this, we could have a flowchart that looked like this. Is your year equal to 1? Yeah, then that's your tuition. No? Okay, elif. Elif, your year is equal to 2? Yeah, then your tuition is 150. No? Elif, your year is equal to 3? Yeah, sure is. You get the cheaper tuition. Nope. Our year must be greater than 3, so our tuition is equal to 60, the lowest possible. So we can see these, what are known as discrete values. There's another term for it that I'm trying to think, and I'm not coming up with it. I guess that they use discrete, but anyways, they're mutually exclusive. Your year could only be 1 or 2 or 3, right? It can't be both 1 and 2. The flowchart's showing that it can't equal 1.2 or anything like that. So it could be replaced with this. Now here's how you flowchart a case, and we don't care because we're not drawing it, but we're going to look at it anyways. But don't just look at your phone because I said that. Let's actually learn it. How come I can't get rid of this part? I don't want to just close it. I guess I will. Get lost. Okay. Like this. Switch based on year. If the year is 1, tuition 175. If the year is 2, 150. If the year is 3, set it to 100. Default, set it to 60. You kind of see it makes a more structured, more terse, more compact flow chart. And it did make the code look a little bit more organized. It didn't exactly make it shorter, right? When I come up here and I look at my case statements, it's not that it made it shorter, but it's more structured. Maybe it's easier to find the code that you needed to modify and read. And, you know, maybe that's easier to read. It certainly is more structured. So if your language supports the switch case structure, then you might want to use it. If you take C++, which I recommend, or Java, which I recommend, both of those, I teach them both. So, hey, if you like my teaching style, great. If you hate my teaching style, then other people teach Java as well. Yes, ma'am?
So what's the difference between the two flowcharts? Is it just the way that they're structured? Or
Yeah, they look significantly different, right?
yeah.
But they do exactly the same thing. They're just coded differently. They're coded differently, and they're structured differently, but the output's the same. And that's okay. You see that a lot in programming. Like when I did this, I rewrote this statement. Where'd it go? I rewrote this statement more than once. I guess I should put the original here as well so that you can see that we rewrote it 3 times. So I'm going to go back to my notes, and underneath the one that says sorry can't watch, and above this one, here's how it looked in the PowerPoint. If age is less than or equal to 12, or age is greater than or equal to 65, and then they had parentheses around it, and movie rating is equal to G, colon, then print whatever. Discount applies, whatever. Okay, so this is 3 different ways of wording it, and they all do exactly the same thing. Almost looks like, yeah, that's method 1, using the whole thing on one evaluation, one line. The if statement's just 1 line long. Here we're using nested if statements, and here we are using both nested if statements and elifs to implement the ors, but they do the same thing. And so you just have to pick which one makes more sense to you. The same is true of the case switch statement. If the case switch makes it look more organized on the flowchart and your language supports it, then yeah, maybe you're going to use it. So in C++, maybe you learn to like it, and so you start using it. Does that make sense? Sure, it's exactly the same. It's just very different structure.
So when you're repeating it, is that the other one?
There's no repeating involved. This is not a loop. Yeah, right. This is just from top to bottom, almost like a waterfall, and then joined back together. These are nested ifs, except I would have drawn my nested going to the right, because you always see me do my trues, going off to the right. And then this is not a loop either. It's just doing one of these things, right? If this was true, then the tuition's 175. If that one's true, if the year's 2, then 150. If the year's 3, then tuition is 100. In every other case, it's a 60. This is showing the same thing. If the year is 1, tuition is 175. If the year is 2, it's 150. If the year is 3, it's 100. And if it's 60 or anything else, if the year was anything else, then the tuition is 60. Is that making sense? Good deal. I'm not going to ask about it on the exam. We're not going to use it in class since our language doesn't support it. But there's always more than one way of writing these things, and you don't have to just do it one way. You do it in the way that looks the clearest on the screen, that makes the best sense to you, and that you think would be easier to modify in the future. So going back to this example, I would certainly not do this. To me, that just looks worse than doing this. I've read enough code that this is pretty clear to me, and so I wouldn't bother have broken it up into the nested if statements, but there's nothing wrong with that. And maybe there are times when we might want to start adding some else's. I'll give you an example, then I'm going to delete it, so don't type it. What if we wanted to modify the functionality so if they were between that age range, but it wasn't a G, then we wanted to print something else. And then if they weren't even in that age range, then we were going to print yet something else, something even different. There's no way that we could write this code using this structure because there's 3 possible outcomes, right? So we would have to break down this structure into something like this in order to accomplish those 3 different outcomes. And I'm not going to draw a flow chart for that. But if you need more than 1 or 2 possible outcomes from an if statement, if it's going to be doing 3 or 4 different things, you're probably going to wind up breaking it up like that. And I'm going to delete that because it's no longer functionally equivalent to that, which was the point of those 3 chunks of code. So the summary. Decisions involve evaluating Boolean expressions. Sounds complicated. What's a Boolean expression? It's just something that's either true or false. Is x equal to 3? Is age less than or equal to, 12? Is the movie rating equal to G? Those are just Boolean expressions because they turn into trues or falses. Boolean just means true or false. It's one of our data types. We have several different data types. We have, integer data types, which are whole numbers. This is way going back, but why not? Integer data type is a whole number. We have float data type, which is floating point with a decimal. We have string data type, which is text with quotes around it. Now, it can even be a number inside quotes, but the quotes make it a string. And then lastly, we have the Boolean data type, which is either true or false, a logical data type. So those are the 4 common data types that just about every language supports. Some languages have a lot more. It turns out that we can define our own data types once we become more advanced, like if you take the scripting class. But fundamentally, those are it. Now the book seems to call both integers and floats a numeric data type. But if I list some data types in the exam, and this is serving as a review, right? If I say 3.1, and then I say 7, and then I say quote, 3.1, and then I say false, which is which? Well, that's got a decimal point, which makes it a float. Yep. Which one of these is the string? While we're talking about strings.
False.
That's not a string. What makes something a string?
Vowel.
The quote. So it's got to be this one. And whole numbers are integers. And then trues and falses are booleans. So there'll probably be some kind of matching question where, some things like this are on one side in one column, and then these are the other. All right. So you use relational operators to compare values. Relational operators compare values. Compare values. I wrote the word math because my brain leaped ahead. Arithmetic operators perform math. So the relational operators are things like less than, greater than, equal to, and then their opposites. Oh, dadgummit, if I hit tab there, it pops up that thing. Just click the escape button or something and use the space instead. The opposite of less than is greater than or equal to. The opposite of greater than is less than or equal to. And the opposite of equal is not equal to. So those are the relational operators. The arithmetic operators are good old addition, subtraction, multiplication, and division. Also, floor division, which produces an integer as a result, so it just drops the decimal point. And then modulus, which means remainder. So modulus means remainder. And then we have star star, which is exponent to the power of. And then using parentheses to group them. Parentheses to group them. The order of operation has a silly mnemonic, PEMDAS. Please excuse my dear Aunt Sally, PEMDAS, which says parentheses are at the top of the heap. That's the P. Followed by E for exponent, followed by multiplication and division, and also exponent, also floor division, and modulus, count as part of multiplication and division, right? Because floor division is just a fancy form of division, and modulus just does the division and calculates the remainder, so they're equivalent as well. And then addition and subtraction, which we know those symbols. Okay, so that's the order of precedence. Order of precedence for arithmetic operators. And then the order of precedence for logic, for logical operators. There's only two logical well, there's three. There's the word not, and, or. But I'm just going to do and or. Not has even higher precedence, I believe. But and followed by or. Because and is logical multiplication. Or is logical addition. And I remember showing you that because the truth table for an or looks like this. 0, 0 equals a 0. 0, 1 equals a 1. 1, 0 equals a 1. And 1, 1 equals a 1. If these are ors. Now I use zeros just because it looks like math, and logically a false is a 0 and a true is a 1, because ultimately that's what computers do, right? But the electricity is either on or off. So false and 0 just mean no electricity going down that particular transistor or whatever. But we can tell that this is logical addition. 0 plus 0 is a 0. 0 plus 1 is a 1. 1 plus a 0 is 1. 1 plus a 1 is, well, you might think 2, but this is logical, so it's either true or false. So that's a truth table for or, which, if I hadn't been about to demonstrate the math, I would have made it all trues and falses. So I could copy and paste that and change the zeros to F for false and the ones to trues. So the only possible way, this I'm going to just put or truth table above that again, just so the eyeball immediately notices that. The only way that or can become false is if both sides are false. Every other time, the or results in a true, because it's either one side could be true, or the other side could be true, or both sides could be true, or result in a true. So how about the and truth table? It'd be easier to copy and paste. I could copy and replace this and just change some of the answers, but I don't mind retyping it a little bit. Here's the truth table for and. 0 and 0. That's definitely a 0 because neither one of them is true. 0 and 1. Well, it's still 0 because both sides have to be true. A 1 and a 0. Still a false. And then a 1 and a 1. That's the only time that it can evaluate to being a true, is when both sides of it are true. Now I said truth table, when it's supposed to be a truth table for and. And so we can see that it's like multiplication. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. And 1 times 1 is equal to 1.
Does that have anything to do with the discrete math you said?
I think that's covered in discrete math.
Okay.
It's been a long time since I've taken discrete math, but I think so. Discrete math, Boolean algebra is what they call it. Pretty sure it is. Yeah, discrete math, Boolean algebra. So when you go and take discrete math, you'll hit that idea again. Okay, and then I'm just going to copy and replace this, putting trues and falses. So I'm going to copy that, paste it, and replace every 0 with a false, and every 1 with a true. You'll see both representations. This is more an electrical engineering kind of thing when you put 0s and 1s there. You know, lack of current or current. There are symbols for and or in circuitry because circuitries use and or. Let me show you those symbols. And circuit symbol. Here we go. An AND gate kind of looks like a rocket ship, a Pac-Man ghost or something on its side. It's got a flat bottom. An OR gate, the OR operation, looks more like a Star Trek symbol. It's got a curved bottom. And then it's got some weird ones, NOR and NAND. That means do that logic, but then flip it. And if the answer was a true, change it to a false. And if the answer was a false, change it to a true. Now, we're not doing math, electrical engineering, so we don't need to care. But that does bring up the last operator, which is not. Truth table for not. And so if you have a false and you take the not of it, if you take the opposite, it becomes a true. So not F equals T, and not T is equal to F. So if you wrote something like this, if not age less than 12, then this just means it's the opposite. So like if age was equal to 13 here, and then we did not age less than equal to 12, is that true or false? Well, let's check it out. Is 13 less than 12? No, 13 is not less than 12, so that would be false. But whoops, we have a not here, so that flips that false to being a true. Now, I would have worded it like this. If age greater than or equal to 12. And that's also true, and it's easy to read. Nots kind of bend our brain just a little bit. The computer doesn't care. The computer does it perfectly. Just like if you start throwing in double or triple negatives into the English language, I will never not go, then your brain has to parse that way, you know, for a little while. It's a fancy way of saying I will always go. I'd rather say I will always go rather than I will never not go. Unless there's a real strong reason. I'm trying to give a flowery political speech and I don't care if people understand it. I might say I will never not go. But otherwise, I will always go is much clearer. Just like this is clearer. And notice that when we had a negative and we wanted to take the opposite, we made it greater than, or excuse me, less than. We made it greater than or equal to. Just like I said, those are the opposites. Why? Because, and this is going to be an error state, so I wouldn't recommend typing it in your notes. If you thought those were opposites, they're not. Because what if age is exactly equal to 12? Well, is 12 less than 12? Whoops. Let's, if you thought that these were going to be opposites, but the age was exactly equal to 12, is 12 less than 12? No, 12 is not less than 12, so that's a false. Is 12 greater than 12? No, that's still false. If you wanted these to be opposites of each other, you would have to change that to an equal then. And then they produce, you know, the opposite result. So that's why I say greater than or equal to is the opposite of less than, and vice versa. The opposite of greater than is less than or equal to. Because on the edge condition, that boundary between the two, they would evaluate to being the same if you did not do less than or equal to, or greater than or equal to, if you did not flip it like that. All right, I'm going to nuke that. So not is just the opposite. Not is the Boolean opposite. Just don't know if you ever watched the Colbert Report, but he always made a big deal about the truthiness of something. Well, it flips the truthiness of it. If x equals 3 is true, then not x equals 3 is false. But again, there's a not in it. I would write it like if x not equal to 3. I think that's easier to understand. I think that's easier to understand than writing it like that. Your mileage may vary. If you'd like using the word not rather than that not equal symbol, go for it. Just like Anna asked about earlier, are those functionally the same? Yeah, they are functionally the same. So why would you pick one over the other? Just because one is clear to me. And if it's clear to you, you go with the same one. If it's the other way's clear to you, then go that way. Because different brains work in different ways, right? So in an AND decision, the question that is least likely to be true should go first. In an OR decision, you put the one that's most likely to be true first. So for a range check, you use an AND to check to see if it's within the range. If you want to see if it's outside the range, you use OR. And I know this is familiar, but we're doing exam review over chapter 4. So for a range check, use AND to check inside a range. Use OR, and this will be the last thing we do before our break, to check outside the range. So do you remember that one that was checking the age of the moviegoer? If age is less than or equal to 12 or age is greater than or equal to 65, we're checking outside the range. So, or if we wanted to check to see if it was in the range, we would do if age greater than 65, age greater than 12. Notice that when we flipped the symbol, we went from less than equal to just simple greater than. And age is less than 65. So we're checking within the range. So we used an AND. Right, like if you're going to see whether something is boiling in Celsius, the range of boiling in Celsius is 0 to 100. So if within that range, you'd say if it's greater than 0 and it's less than 100, then it's not boiling, it's water. If you check outside the range, you'd say if it's less than or equal to 0 or greater than or equal to 100. Now I may have gotten those equals wrong, but the thing is right. You'd use an OR. If it's less than 0 or it's greater than 100, then it's not liquid. I know I stated that slightly wrong regarding using the terms boiling or not because I didn't ever use the word freezing, and less than 0 is freezing. So if temperature is less than 0 or the temperature is greater than 100, this is in Celsius, it's not a liquid. If the temperature is greater than or equal to 0 and the temperature is less than or equal to 100, it is a liquid. Again, we used AND to check within the range, and we used OR to check outside the range. All right, that's the last bullet point. So let's take a break, come back in 5 or 6 minutes. All right, we're done with that chapter. We're going to zip a little bit into chapter 5. You have absolutely no need to worry that if I introduce something new today from chapter 5, it's not going to be on the exam. That'd be totally lame. Looping. Now, there's not going to be a lot of looping on the exam just because we haven't hit the chapter for it. On the other hand, we have mentioned looping as a programming structure way back in earlier chapters. And so we've already seen that it's a diamond symbol and that it repeats the code. And so if I ask you for the programming structures, then there's only three. There's sequential, there's selection or decision, I forget which they call it, which is like if statements, and then there's looping, which is while. Sequential just means one after the other. And you can build any series of logic just by stacking those things or nesting those things, right? You could put a loop inside of an if, you could put an if inside of a loop, you can put a whole bunch of sequential structures inside a loop. You can have an if followed by a loop in separate blocks, right? You just stack them together, like a Jenga tower or something, I don't know. But the fact that you're stacking them is why your program really should only have one start, one stop, not have any dead ends, because the if statements eventually join back up in an end if, and the while statements just loop. They have a line going back to the diamond and another line dropping down, which we'll see in the PowerPoint. So looping. Looping makes computer programming efficient and, I like this term, worthwhile. All right. Certainly makes your coding more efficient. If you're going to repeat a calculation 100 times, it'd be really lame to copy and start pasting that 100 times in your code. If your turtle is supposed to draw 20 triangles, then don't put drawing that triangle 20 times in there. Make a loop and then have it draw inside that triangle so that the code is 20 times shorter. So you're writing one set of instructions that operate multiple times. Less time required for design and coding. Fewer errors, right? Because if it worked on the first loop, it ought to work on the last and everything in between. Shorter compilation time. All right, I trust them on that. And so the loop is a structure that repeats some conditions as long as, repeats some actions as long as the condition continues. They say that it's a dual alternative selection structure. I don't buy that because if was a something or something else, if it was dual alternative, and if it was single alternative, it was single do something or nothing. I consider this more like a single alternative, but whatever. This is a loop. If this case is true, if this condition is true, then it does some code and then it comes back up and it checks the condition again. And when I draw it, I usually make the line go directly to the diamond rather than above it, but both are correct. So do some declarations, do some so-called housekeeping, which is just setting up, like opening a file if you need to, open a file to read from or establish a connection with the internet or whatever. Not end a file. Are we not at the end of the file? That's their sentinel value. Remember that a sentinel value is the value that stops a loop. I will mention that because that may be on the exam since we talked about that in chapter 1 and 2. Sentinel value is the value that stops a loop. For example, enter -1 to quit, right? Enter a number or -1 to quit. -1 is the sentinel value. And then, or the EOF, end of file. That'd be a sentinel value. EOF is the sentinel value. Do you wish to repeat Y or N? N is the sentinel value. Sentinel value. I should not have taken Ambien last night. I can't type today. All right, there we go. So a loop is a body of code that repeats while a condition is true. That's why our keyword is while. Some languages, which is, I don't recall if this text discusses it or not, have a do loop. And the difference between a while loop and a do loop is a while loop says, while something is true, go ahead and do it. And the do loop says, do something while this condition is true. So it goes ahead and does it before it even checks. This language doesn't have do loops. It's used less often than while loops. And there's no logic that you can implement with a do loop that you can't hack together with a while loop. So, the guy who invented it just said, nah, don't need it. And when I said body, it could just be a single line of code. Right? If we look in here, in our pseudocode over here, detail loop is just a single line of code, but a single line of code is still a body. So here's the whole body from here to here. It's everything that's indented at the same level after the start of something. Yeah, like if this is Python, you'd have a colon on the line before, right? But everything after the colon is a body. If we go and look at our code, we've had several bodies of text, and the whole thing is considered a body. From here to here is a body, but we also have some kind of sub-bodies, right? We have a body of code. I'm looking for a place where we had more than one line of code. I know we had an error message on the invert. Right? Yeah, we had two statements here in the if. Well, that's a body. We could have a million statements there after the if, and that would all be a body of text because it was all indented under the if. Fancy schmancy way of saying that is that this code is subordinate to the if. Thankfully, our textbook doesn't say that. Subordinate, well, it's contained within the if. So it's the body of the if statement. This is the so-called header of the if statement because the header defines what condition has to be true before it goes in here. And this is the body of the else clause. So as long as the condition remains true, the statements continue to execute. While the number of lines drawn in the square is not equal to 4, keep drawing lines and turning left or turning right. So we get to control the number of repetitions. There's kind of two ways of controlling it. One is you could just have a counter, right? X is equal to 1, keep going, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's called a definite loop. A definite loop is one where you know where it's going to start, you know where it's going to stop, and you pretty much know, the number of times it's going to repeat. Right? So if we're going to count all the even numbers between 2 and 100, we know we're starting at 2, we know we're ending at 100, we know we're skipping by 2. That's a very definite loop. Then there are indefinite loops. Enter test score or -1 to quit. You don't know whether the user's going to type -1 as the very first thing or whether he's going to enter 100 test scores. That's an indefinite loop. You in advance, the program in advance doesn't know how many times it's going to repeat. Now, if it's a definite body of loop, you do know, right? Like if it was enter, sales for January, enter sales for February, March, April, May. It's probably going to be a definite loop because it's going to ask for 12 pieces of data for all the months. And as long as we only have 12 months, we're going to be good. If somebody passes a law that says it's going to be a 13th month, isn't it kind of weird, this is just kind of trivia, that if oct, like octal, like an octagon, means 8, and nov is like Greek or Roman for 9, and deca, like decade or decimal, means 10. Those are not the 8th, 9th, and 10th months. So Julius Caesar and Augustus Caesar squeezed their months in during the summer because previously there were only 10 months. And so they made an 11th and a 12th month right in the middle of everything, causing the counter down at the end of the month. Okay, anyways, who cares? But they didn't rename those last months. Alrighty. So the loop control variable, if it's a definite loop, can be initialized before entering the loop. And then it's tested, and then you have a body. So like this. Say we want to print the word Bob 10 times in a row. Well, we could set a counter. Let me go to the bottom and end our green text. We could set a counter, or I could just use a single letter. How about I? Make it easier to type. I is equal to 1. That's going to be our first number. And 10 is going to be our last number, so we're going to do while I less than or equal to 10, colon, single colon, not double, print, parentheses, quote, Bob. And it's going to print Bob 10 times in a row, except I forgot something, so it's going to repeat Bob infinitely. Called an infinite loop when it doesn't stop running until you kill the app. Right? Okay. That's because I never changed the value. This isn't an if statement where it just does one thing and then it keeps going. It's a while. So it keeps repeating this until I is no longer less than or equal to 10. Now since I is equal to 1, it's always going to be less than or equal to 10. So we need to change I. So I plus equals, no space, 1. Now we've already been using things like that, but we said I equals I plus 1. It means the same thing. And when you go on to take Java or C Sharp or something, you can replace plus equals 1 with I plus plus. It's even shorter, but that's not true of this language, so I'm going to backspace over it. All right, now to work. Now to print Bob 10 times in a row. Bob, 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 10 times. So that's 3 things we did. We set the loop control variable. We tested the loop control variable. And then there's a body of code. And then we update. Now I said 3 things, but that's really 4 things, isn't it? But technically the update is inside the body of the code. But let's see what the PowerPoint has to say about it. Yeah, so you have a loop control variable that you initialize before entering the loop. And then the loop control variable is tested, and then the body of the loop must alter the value of the loop control variable, or else it's an infinite loop. So going back to our notes, we have kind of these steps. 1, initialize loop control variable, which in our example up here is I. Could be anything, right? Could be age, right? Well, your age is less than something. It could be month number, if your month number is counting from 1 to 12. And then 2, test the variable with the while line. Now this should have all been green texted, right? I guess I'll put some hash symbols in front of it. And then 3, the body of the loop, and then kind of a 3a, update the value of the loop control variable, which if I had to type too many times, I might just start calling LCV or something like that, but there we go. And we can see the relationship between the loop we wrote up here and these comments. Initialize, test, that's the body, and the body actually consists of both things, and this is the update. Why don't we just add those as comments to our code? So I'm going to go back. Oh, come on, it's doing it again. I hate that. Escape isn't even working. All right, forget it. I'm not going to update it. But you can tell. This is step 1. That's step 2. These things are step 3, and that's kind of 3A here. I wonder if PyCharm is as annoying about that. Might have to switch people to using PyCharm optionally. But it's PC only, so the Mac users, I think it is. Mac users wouldn't like it. Anyways. So the repetition is controlled by the counter or a sentinel value. The sentinel value is when you're testing it against, While score is not equal to -1. Make sure that they didn't type in a -1. While the repeat variable not equal to no, because we asked, do you wish to retry? Do you wish to repeat? Okay, well, this certainly is slow. One reason not to use Python. PyCharm. It's already taken a minute and we're not even into it yet. Okay, forget it. So, two kinds of loops. Better start green testing it. Two kinds of loops. A definite loop, like a counter loop, just as shown above. Definite loop, we know where we're starting, we know where we're ending. We know in advance where we are starting and ending. I is going to become 1 to 10. And then there's indefinite loops. We don't know in advance when we're stopping. So we use a sentinel value. You're reading data from a file, you don't know how long the file is going to be, so you're going to keep going until you hit end of file, right? So that's an indefinite loop. Or you're going to ask the user for a series of values, but you're going to let them bail out early with a -1 or something. Or you're going to ask them if they want to repeat the game. Play again. Yes, no. Right? That's an indefinite loop. Pac-Man's running around the screen, and you can keep playing forever as long as you don't lose your number of lives, right? So while number of lives is greater than 0, but it's really kind of an indefinite loop because they could be winning extra lives, right? So we didn't know in advance how many lives that they were going to be able to accumulate and play. Sorry, PyCharm, you had your chance in the sun. Get lost. So if we were going to flowchart our little teeny tiny loop up here, if you drew the other flowchart, go ahead and go back to it. Maybe I'll copy the code and paste it as pseudocode. I mean, not pseudocode, but in a comment block. So I'm going to grab a text block, paste my code into it. I'd like it to be aligned left on the margin. Good enough. Now this little snippet of code doesn't have a start and a stop, but we're just making a rule that all of our flowcharts begin with a start and a stop. So if this is pseudocode, we'd add that. So start. I'm going to need a stop, so why not just go ahead and add one with a copy paste. Control V, Control C. All right, I is equal to 1. Not that you can read that, that's pretty teeny tiny. Let's increase the size of the font. All right, I is equal to 1, that's math. That's a set statement. Process block. Set I equal 1. And then there's a while. While I is less than or equal to 10. Well, whiles are decision diamonds. While I less than equal to 10. And if that's true, then we're going to jut off. I'm going to tab it over to the right. So I need to draw a line going off to the right so we can print the word Bob and then add 1 to I. Now I'm skipping drawing the lines, but I would count off on my assignment if I saw myself skipping lines, so I better put them there. Alright, so this is a print, so it's a good old quadrilateral tilted rectangle. Print or output Bob. And if you even feel like putting parentheses, I don't care, because we already have the code here and we're making our flowchart match our code. I'm not making it exactly match pseudocode, or else I'd change the word output and all that. And I guess I should have. Why not? I'm going to change that print to the output, make it technically correct. Alright, and then the next statement is some more math. I equals I plus 1. Or I plus equals 1. So that's a process block. I plus equals 1. Or I equals I plus 1, whichever one you like more. And then it has to go back to the while. And I know I've said this a couple of times, but the book shows it going above it. If you like that, that's cool. I show it going straight to the diamond. If you like that, if you want to be like me, doesn't matter to me, you'll get points either way. I draw it going back. And I kind of prefer to put it underneath it like that rather than going over the top, if I can manage to do that. Well, aren't you being annoying? There. And then lastly, the stop. Now, I've lined all this up in a single column because it kind of matches the way the code is lined up, right? Because all of this stuff is the unindented stuff, and these two things are the indented stuff. But if you run out of room or you want to not line things up in columns, it would have been totally cool for me to take this guy and move it up there. That's perfectly good. Or if you're feeling like making that jut off to the left like we do, right, on the if statements, that's okay. But I try to make whiles go straight down. Come on. And as mentioned, the book would not put the word while there, and you would know that it was a while just because it looped back to itself. I like seeing the word while there, but I'm not going to give you fewer points if you leave it off. I will count off if you draw it like this, if you make it look like an if statement and you hook it up at a circle, because that's no longer a while loop, it's just an if. So this code is repeated as long as this condition is true. So using a definite loop with a counter executes a predetermined, nice word, number of times. So that's a counter-controlled loop, or a counted loop. And the program counts the loop repetitions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the loop control variables are altered. They can be incremented, or what if you want to count down? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, lift off, right? That's called decrementing. Incrementing is adding, decrementing is subtracting. So why don't we add that to our notes? So, loop control variable, adding one to it is called incrementing, which you can do with I plus equals 1. By the way, if you say I equals plus 1, that's not going to work. It'll just set it equal to the value 1. It won't add anything to it. And then subtracting 1 is called decrementing. Decrementing. And you can say I minus equals 1. Or if you like writing it out, I equals I plus 1, or I equals I minus 1. Totally cool. So increment can be done as I plus equals 1, I equals I plus 1. I kind of shouldn't have chosen a variable I because it looks like an L and a 1, but I think people are okay with that. I'm sorry about that. I need to go around and make sure that everybody's doing okay. Usually I remember that I is a lousy variable name because it's hard to see. Or in some languages, I++. In Java and C, C# and whatever. In some languages. And then the decrementing. I minus equals 1. Or I equals I minus 1. Or I minus minus. And again, in some language. So ditto. So definite loops are also known as counter-controlled. You do counting loops so dang often that there's a special keyword for it. For. Counting loops can often be done as, quote, for loops. What do I mean by that? Let's give an example of that. I'm going to stop using I. For month equals 1, no. For month in range, parentheses, we're going to start at 1 and we're going to keep going as long as the month is less than 13. Now if you want a variable to count from 1 to 12, it feels right to put 12 there, but this language actually makes you go to 13. And we want to add 1 to it each time. So we could optionally say, I want it to increase by 1. Why would you do that? Because you might want to increase by tens or hundreds or something, in which case you'd change that to a 10 or 100. This is this, well, let's finish this. And then print the month number. Good enough. That's going to print out the numbers 1 through 12. Heck, we could add the word month equals in front of that, right? Month, quote, month equals, end quote, comma, like that. Just so we know what the heck we're seeing. It took 2 lines to do that. Whereas when we were printing out Bob, it took 4 lines of code. So that's more efficient to express. We set the initial value here. We initialize it. We set the whiles, the terminating value, and we set the update all in 1 line. That's why it's only 2 lines rather than 4. Let's run it and make sure that I better do a walkabout, make sure we don't have syntax errors. There, printed out months 1 through 12. I will reiterate that if you want to count up to 12, you make that 1 more than 12. Why? Because that is the same as while month less than 13. Not less than or equal to 13. In math, you may have done the terms, what were they called? Inclusive or exclusive, right? X is between the values of 3 and 10, inclusive. Well, this is between the values of 1 and 13, but the 13 is exclusive. It doesn't reach it, so it's only 12. It keeps going as long as the month number is less than 13. Now, in some languages, you can actually use the number you want to stop at, because this is what it would look like in C# or Java. You don't have to type this if you don't care a whit about those languages, but it would look like this. For, parentheses, month equals 1. We're starting at 1, semicolon. Month less than or equal to 12, semicolon. Month plus plus, or plus equals 1. That's how you would do it in those languages. Same idea, right? You're picking a starting point, you're picking a stopping point, you're updating it, but you have the freedom in those languages of expressing this how you want. You could change that to less than 13. It would form the same. It would still count from 1 to 12. It would match Python syntax exactly, but you can make it do that, and you can even make it more complicated in those languages, right? You could say month is less than or 13, and right, age is not equal to 3, right? Something like that, right? We have made this stopping condition really complex there. All right, we don't care about that in this language. Python doesn't support putting multiple clauses inside the for loop like that. So I'm just going to say C++, but just know that C# and Java and stuff like that are kind of variants or children of C++. So just like the if statement, we cannot do this. While 1 is greater than, how do you express a range in math? While 1 is less than or equal to x, which is less than or equal to 12. Languages don't support that. Looks spiffy. I know that in some math classes you've been able to do that, but the reason why is that less than or equal to is a binary operator, meaning it needs two parts. And so if we analyze it, here's the first part. Is x less than or equal to 1? Oh, I expressed that wrong. These should be greater than. See how long it's been since I took that math course? There we go. Right. So while x is greater than 1 but less than or equal to 12, but it doesn't work because this is a Boolean operator, meaning it has two operands, and this is a Boolean operator, meaning it has two operands. So let's break it down. If we evaluated that and then it turned out that that was true, then it looks pretty weaselly. While true is greater than or equal to 12, what the heck? Nope. That doesn't work. So that syntax is inaccurate. Doesn't work. Looks good, doesn't work. So let's remind ourselves that less than or equal to and the other comparison operators are binary, needing more than one operand. And you just ran into this by accident. So if you do while I is less than or equal to 10, less than or equal to is the operator. I and 10 are the operands. They're the pieces of data that the operator needs. So if you accidentally slip while typing this and you leave off the I, kind of looks okay if the statement in front of it says I is equal to 1. But it's a syntax error because it's a binary operator, it needs two operands, needs two pieces of data, one on either side of it. So it would have to be like that. Why did I put 1? See there? I botched it. Okay. Lots of things are binary operators. Addition, subtraction, all the math symbols, all the comparisons, all the logicals. No, that's not true. And an or. However, not, I didn't finish this sentence, equals binary operators. However, the not keyword only requires one thing, just like -1. That minus is only got one operand, so it's called a unary operator. I'm going to delete that example, but not is a so-called unary operator because it only takes one piece of data. The example being if not x equals 0. Right? So not reverses the truthiness of this part. There's not something on either side of it, right? There's nothing blah, blah, blah there. If blah, blah, not that. It's just if not, blah, blah, blah. So I'm going to change that expression right there to condition, right? If not condition. There's only one operand. There is no other. So unary meaning 1. The rest of them are binary operators meaning 2. Not binary because they turn into 1s and 0s, like we were counting a couple days ago. Just meaning 2. So a counter is the variable that counts the number of times an event has occurred. Now they say it usually starts with 0. Now that's a computer science thing. I keep saying a computer counts, starting with 0. Well, we've just seen that you can start counting at 1. You could start counting at any value. If you need to count from 100 to 200, no problem. Howsoever, there are something called arrays or lists, and when you're using arrays or lists, the index value always starts at 0. And you start doing that so often that I'm comfortable, that's why I have a homework 0, just to remind you that computers start counting at 0, and I should put in parentheses when dealing with arrays and lists. So here we go. They put the num count is equal to 0. Oh, look at that. They use the word num rather than set. I like the word set. They use the word num. That's okay. The reason I like the word no, I won't even get into it. Okay, so they set the counter equal to 0, and while the counter is less than 4, we print hello, we add 1 to the counter, we loop back. So it's only going to print hello. It is going to print hello 4 times, but not times 1, 2, 3, and 4. Since the counter starts at 0, it's going to do 0, and it keeps going to less than 4. 0, 1, 2, 3. Still 4 times. It just counted starting at 0 and ending before it reached 4. So that's 3 times. Here's the initialization. We talked about the 4 steps. Here's the test. Here's the body of code, and inside the body of code, the loop control variable is altered. Now I've been saying updated. Did they use updated in some places and altered in the other? Okay, they've been using alter the whole time. Great. Go back to my notes. Scroll up to where I had my loop, and I'm going to change that word update to alter. Doesn't matter. Same word. I like update, but whatever. I'm going to update my tax form. I'm going to alter my tax form. Same thing. So if we wrote this program and then we ran it, we'd see on this very difficult to read green text on black. Oh no, that's completely different. This is one of those loops that asks you if you want to repeat. Right? If we look at the code, do you want to continue? Y or end? You press Y, it says hello. Do you want to continue? Y or end? This is getting kind of tedious, but we press Y again. We still think it's fun. Do you want to continue? Y. Do you want to continue? Nah, we've had enough. Goodbye. That's an indefinite loop. If we were maniacal about it, we could have repeated it 20,000 times in a row. If we knew in advance what it was going to do and we thought it was boring, we could have chosen no right from the beginning and it would never have printed hello. So it's an indefinite loop. So the functioning loop, provide a starting value, test the loop control variable, and alter the loop control variable within the loop. So you can nest loops inside of loops. The outer loop contains the other loop. The inner loop has to keep going over and over and over until it finishes, and then the outer loop can repeat once. Let's play with that idea. Let's make a month counter that goes from 1 to 12, and let's make a week counter that goes from 1 to 4. So month equals 1 while month is less than or equal to 12, colon, print, parentheses, quote, month equals, end quote, comma, month, in parentheses. That's our outer loop because we're going to add the word while here, and it's going to be inside the other loop. Now we need to initialize another variable, which I'm going to call week. So week equals 1. And while week is less than or equal to 4 weeks in a month, we're just pretending, colon, tab over, print, parentheses, quote. How about a \t for a tab? Backslash is the one under the backspace. \t. And then week equals, end quote, comma, week, in parentheses. Now for our inner loop to work, it has to have that update step, that alter step. So week plus equals 1, not slash at the end of that. Week plus equals 1, and then back tab 1. Let's put our end while comment. Now for this outer loop to be completed, it has to alter its own loop control variable, which was month. So month plus equals 1. Remember, no space between the plus and equals, and don't make it equal plus. And then lastly, one more end while, totally back tabbed against the margin. I think I'm going to go back and add some comments to the while statements, calling them outer loop and inner loop.
Under second print, do you mean week?
This is the word week, but it's going to have a tab in front of it. So that's what that \t means. Yeah. We need to talk a little bit more about the backslashes. Thank you for pointing that out. There's 2 backslashes that are really important to us. All right, enter X, whatever, 1. Okay, you see what it did for those months? Ignore the fact that we have a month counter up here, right? This is where the good stuff started. Month is equal to 1. Week is equal to 1, 2, 3, 4. Month is equal to 2. Week is equal to 1, 2, 3, 4. You see the inner loop ran 4 times for every 1 time the outer loop got to so-called iterate. Iterate means 1 repetition. I think the book may even call it something else. But it's the number of times it repeats. It's the number of times it iterates. So here it goes. The inner loop has 1 iteration, all of its iterations, all of its repetitions, and then month is updated 1 more time. So the inner loop has to finish before the outer loop can do 1 more thing. Oopsie. So in our code, that's what we're seeing, is that this while is the outer loop, and this while is the inner loop. There we go. The above is a nested loop. So it has an inner loop, not an inner lopo, inner loop, and an outer loop. The inner loop does all its repetitions before the outer loop can so-called iterate, in parentheses, per end quote, parentheses, repeat, in parentheses, once. All right, \t. There's another one, \n. Let's just set that up. Print, parentheses, quote, hi, \t, Bob, exclamation point, \n, how are you doing, question mark, \n. T means tab, N means new line. So, \t equals tab, \n means new line. And there's a couple more, but those are the really, really important ones. You can use tab to try to line things up in columns. Now there's a better way of lining things up in columns, but \t is a kind of a quick and dirty, easy way of doing it. Yeah, try that again. All right, so it printed hi, tab, Bob, it went to the new line, it went to the new line, it printed how are you doing, it went to the new line once more. So that's all that tab and new line mean. All right, we're going to repeat this month and week counter, but we're going to use for just because. I don't care if you remember the for loop yet. We're stepping ahead into the future for a moment. For, why don't we, yeah, for month in range 1, 13, 1, start at 1, keep going while the month is less than 13, that way it'll count 1 to 12. Adding 1 each time, close parentheses, colon. For week in range, parentheses, we have 4 weeks, so we're going to start at 1 and go as long as week is less than 5, so it'll count 1, 2, 3, 4, updating by 1, colon. Now let's print, and this print statement is going to be a bit longer because we're going to throw a tab in it. And we're going to print 2 things out rather than just 1. We're going to print both the month and the week. So, month equals, end quote, comma, month. But we're not done yet. We're going to print 2 things on this line. So, comma, quote, \t, week equals, end quote, comma, week, in parentheses. Now that's kind of cool because it took us only 3 lines to do what took like 8 or 10 lines up there. That's the advantage of for statements, because for statements do all 3 things in one line. They set the starting point, the initializing, they set the test, the comparison, and they set the alter, the update, all in one line, all in the header. So that's saving 3 lines of code for every 1 line of the for loop. So it's a lot shorter. Plus, we only have 1 print statement rather than 2. Let's run it, make sure there's no syntax errors, and then I'll go and test y'all, make sure it's working for everybody. Okay, there, you see what it's doing. Month 1, tab, week 1. Month 1, week 2. Month 1, week 3. Month 1, week 4. 2-1, 2-2, 2-3, 2-4. You can see, again, that week is repeating 4 times for every 1 time that the month is updated. So that's a nested loop, just like the other one was. So for loops are awesome because they let you specify a beginning point, an end point, and the alter value, the increment value, all in one fell swoop. We haven't hit that in the PowerPoint yet. Let's pause this. This is absolutely not something that we have to know at this point in the book or anywhere in the book. What if you didn't want to go the new line every single time you hit a print, right? Print, go the new line. Print, go the new line. What if I didn't want to do that? Well, a lot of languages, it doesn't go to the next line every time you hit a print. You have to add that \n, or you have to do something else. Well, in this one it goes automatically just because Python inventor wanted to make it as easy as possible, but if you want to stop it from going to the new line, you can do that. So let's do this. I'm just going to print a blank line there, and then I'm going to print hello, end quote, comma, and then I'm going to type the word end, E-N-D, equals quote, space, quote, end parentheses. And then I'm going to print something else. Print parentheses, quote, Bob. I seem to be stuck on Bob. End quote, in parentheses. That's going to print hello and Bob on the same line. What it does is say don't end with a new line. If I change that space to a \n, don't do that. It would do just like it normally does. It'd print hello on one line and Bob on the next. But if we change that \n, which is just assumed it's the default behavior, to something else, like comma space, then when it runs, it's going to print hello Bob all on one line. Like that. So, there may be some time in the future when we want to take advantage of that.
How do you get the comma in there?
I made that part of the end. I'm sorry, I updated that while you weren't watching. You see that there? Yeah. I could put anything here. Like I could put ... I'm sorry I didn't call it out when I made that change. And now it says, hello, Bob. So whatever you put in here, it's going to do. And if you put a \n in there, it's going to do just like it did before, which would be silly. I would not specify that, right, if that was the case. I'm going to go back to making a comma space now. All right. Let's do a little bit more review. This is going to be earlier chapters. I tried to write down everything we were doing a review as we went. Okay. Wait. Sorry, if I pulled it up on the computer, it'd be faster, but then I couldn't type the notes. Or I could, but you'd see the test as well, which is not exactly what I want. Alrighty. Okay. So, if I give you an example of pseudocode versus an example of Python, know which is which. Know the diff between pseudocode and Python. One easy way of knowing is, the easiest way to spot it is if it has the word start and stop without comments, it's pseudocode. Right. But Python is the programming language. Pseudocode is what we've been putting inside the green stuff. Right? So start, set x equals 1, stop, that's pseudocode. Is pseudocode. And then just x equals 1, or maybe putting a comment, start if you want, and stop, but those aren't necessary, is Python. So if you see the word set in it, see the word set, then it's Python. Ought to make sense. You know what a flowchart looks like, but that's another one of the things, right? If I show you a flowchart and I list 3 choices, pseudocode, Python, or flowchart, if it's a picture, it's a flowchart, right? Logical diagram, picture is flowchart. Okay, know the difference between a syntax error, a runtime error, and a logical error. Syntax error is a typo. Uppercase, lowercase. You left the colon off, right? Runtime error is like divide by 0. So, error doesn't show until the program is running. And then crashes. And a logical error. Program just doesn't do the right thing. It was supposed to count from 1 to 12, and instead it counts 0 to 11. It's a logical error. It's supposed to print boiling if the temperature is 400, and instead it prints freezing. All right. What is the smallest unit of information a computer can handle? Smallest unit is a bit. What is a bit? It can only have 2 possible values. What values? And it's not true or false. Remember when we were doing all that binary math? Zeros and ones. And then bits are grouped into bytes, which are 8 bits. Just remember that for if and while, you must use double equals. For assignment /set, use a single equal. Remember, if and while require a colon at the end. What is it called when you add 2 strings together with a plus sign? Like if I do this. Print hello space end quote plus quote Bob. Now I've always used commas in the past, but I can use a plus sign and it's going to print hello Bob. Or it's going to crash because I use something else. Where did I type picked? Oh, somewhere way down there. All right. Yeah, it printed out hello Bob. These strings were added together, but you don't call them adding strings. You You don't say the strings were added. If you're an English major, you might say it was appended. But instead, we're computer gods. We're going to call it concatenated. Concatenation or concatenated. So it's not math in that case, right? If I print out, I'm just going to go to the shell and demonstrate this. If I print 1 plus 2, it's not going to print 3 because it's not math, because those are not numbers. They're not floats or ints. They're strings. So it printed out 1, 2. The 2 was appended to the 1. And so the strings stop it from being math and cause it to be concatenation. The difference between concatenation and using a comma is that if you use a comma, it puts a space there automatically inside your print. And if you use a plus sign, you have to put the space there yourself. Almost done. All right. If you have some code that looks like this, t dot forward something, right? Your turtle's going forward, and then your turtle's going to the left or the right, and it goes like 90 degrees, and it repeats those steps until we've drawn 4 lines. Is that a square or a triangle? It's a square because it's got 90-degree angles, right? So, what if it did this? T dot forward 100, and then triangles have different angles. They have angles of 120 degrees if it's a perfect equilateral triangle. And then that was repeated like that. That's definitely a triangle. 3 angles, 3 lines equals a triangle. 4 angles, 4 lines equals a rectangle. Now you may think that's just obvious, but I show that code and I ask what it draws, one of those others, and lots of time people pick the wrong one. So, calling it out. Now I just need to edit this question. But what are the place values in binary? They look something like this. 8, 4, 2, 1, right? What are the place values in decimal? And apparently I've forgotten to start green screening, right? I should have, after that print, hello Bob. But anyways. What are the place values in decimal? 1,000, 100, 10, 1. Technically, this is 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and 2 to the power of 0. And technically, this is 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, and 10 to the power of 0. So if I ask, show why 1101 is equal to decimal 13, that's 8, That's a 4. There's no 2's, and that's a 1. So that's equal to 8 plus a 4 plus a 1. That's enough to type. You don't have to do powers of 2's, and you don't have to use an equal sign or anything if you feel like it. There we go. Show why. That should not have been how why. All right, is Python, Java, and C++, are those high-level or low-level languages? Remember, low-level means you're controlling the computer directly, like with zeros and ones or short little codes. We're not using zeros and ones and short little codes. We're using English-like words. So that makes them high-level languages. All right, we are done. Let's make a Dropbox.
Do you want us to submit both the flowcharts?
Sure. If you drew the flowchart, why not upload it so it's available to yourself? Okay. And there's going to be a very simple flowchart to draw. The exam will occupy the entire class time, but I'm not expecting it, like most people, to get done like in 40 minutes. And if it takes you longer, that's okay, because we're here for 2 hours or more, right? Make a Dropbox.